Okay, so we've got some units on here, some of which are equal to each other. Your task is to decide which ones, but first of all, let's just have a look at what some of these units are. So, Sandy, what's this? What was that 1 GB? 1 gram. Excellent. Yes, thank you very much. Let's see. Shiana, what about this 1L?
1 litre.
1 litre. Brilliant. Okay, so we've got a range of units in here. And not only have we got 1 litre, but we've also got 1 millilitre. So these little M's are, and C's and stuff are just smaller versions of a bigger unit. They are all, apart from one, standard scientific units. But some of them are equal to others. So, for example, actually, does anyone know what 1 cc is before we go any further? 1 cc.
Cubic capacity.
Cubic. So close, Veronica, so close. Cubic centimetre. And it's a measure of volume. So, oops. Excuse me. This is the best game on here. So, 1 cubic centimetre. Okay, so there are some other units on there which are equal to 1 cubic centimetre. Any ideas as to what those units are? Let's see. Ollie Curry up at the front. 1 centimetre cubed. Excellent. Do you want to come and drag it into the yellow circle? That's work, Ollie. Thank you. Okay, so 1 cc is equal to 1 cubic centimetre, and actually cc is just a different way of writing cubic centimetre. That actually is the proper one, centimetre cubed, but 1 cc is another way of doing it. You'll find cc's in engines, motorbikes, and cc engines, which means cubic centimetre. Okay, so we've got 2 units which are the same. Let's see, somebody from the middle row. There are some other units which are equal to 1 cubic centimetre in the outside the yellow circle. Any guesses? Hannah. Come and, if you're not sure about one, come and pick one at random and drag it into the yellow circle, and we'll see whether or not it goes in or not. Gram, excellent, good guess, Hannah. Well done. There are some conditions for these things to work, but for the purposes of this, 1 cc, 1 centimetre cubed, and 1 gram, we can consider them all to be equal. Okay, someone from the back row. There is one more. That is equal to 1 cc, 1 centimetre cubed, and 1 gram. Any ideas? So the back row. Fiona looks like she desperately doesn't want to come up. So come on, Fiona.
Yeah, come on.
Just take a guess. And come and drag it into the.
I think it's 1.
Oh, it's a full house, Fiona. Good work. Fiona et al. Okay, yeah, these ones don't go into the yellow thing. Yeah, we get training on this. Okay, so yeah, we have got some equal units. There is a condition of this. Like I say, this is in the next slide, so don't worry about writing this down just yet. But actually, does anyone know what the conditions might be for this? This is for a particular thing. Any ideas what that might be? For a particular substance, more specifically. Shall I say that again? Yeah, it is. It's for water. For water, actually there is another condition which we would attach to that. We'd have to say water at room temperature. Yes. Roughly room temperature. Water at roughly room temperature, 1 centimetre cubed of it, 1 centimetre cubed is equal to 1 millilitre, and actually that holds for any fluid. But it's the 1 gram. Water, 1 millilitre of water weighs 1 gram at roughly room temperature. So there's a relationship between all of these things. Any other liquid, probably like mercury for example, 1 millilitre of mercury weighs a hell of a lot more than 1 gram. Okay, so first page of notes, please take that down. Okay, just quickly on this word calibrated. If I say to you, how is this level cylinder calibrated, would you guys know what I meant? Can anyone tell me what calibrated does mean? Yeah. You can actually calibrate something in terms of accuracy.
Yeah.
Yeah, so you can have it calibrated in terms of accuracy, but actually, yeah, in this case, what we're talking about is actually the markings on the piece of equipment. So this is calibrated in centimetres cubed, and it gives 100 millilitre markings. The reason these units are important is because this one's calibrated in millilitres, this one's calibrated in centimetres cubed. But actually what we know from this is that millilitres and centilitres cubed, or centimetres cubed, are actually the same thing. So someone might say, well, 10 cc's of saline solution, and you could go and grab a measuring cylinder that was calibrated in millilitres and measure out 10 millilitres, and that would be the same thing. Okay, so that's where, in practice, these things can be of use. We're going to have a look and test the accuracy of these different pieces of laboratory equipment later on this morning. This morning. There is always some information on the pieces of equipment which tell you about how it's calibrated. I want you guys to have a look at that when you're looking at the different bits of equipment that we're going to test. But we're not there quite yet. But different bits of equipment can be calibrated in different ways. But what this relationship shows us is that actually, particularly for these things, you can get measuring cylinders which are calibrated in cc, centimetres cubed and millilitres, and actually they're all the same. Okay. Right then, so we've got this relationship between the units. When we're doing an experiment, we also need to be able to do apparatus diagrams. You can do apparatus lists. I prefer apparatus diagrams because usually you would put the apparatus together as if they were mid-experiment. So not only does an apparatus diagram show you what's going to be used, it also shows you roughly how it's going to be used, how the pieces of equipment are going to interact with each other, which is kind of important. And it allows you to start thinking about how we're going to set this experiment up. So, in order to do an apparatus diagram, you need to know how to go about drawing different pieces of equipment. Now, do I need to be an artistic genius to draw an apparatus diagram? No. We want to go for the simplest possible way of drawing a conical flask, which is what this thing is. And actually what we do for scientific experiments is just imagine the things being cut down and the middle. So two-dimensional representation of that. Which means that, if you guys can copy this down, this is a measuring jug or a beaker. Basically looks like that. Nice and simple, just as if it's been sliced down the middle. The conical flask, which is obviously called that because of its shape. Similarly, in terms of drawing. When you're drawing an apparatus diagram, I would want you to label it as well, just in case your drawing is as good as mine. In which case it just needs a bit further clarification of what the thing actually is. The tall thing is a measuring cylinder. That's that. And that will look something like that. And then there are these things. Does anyone know what one of these is? Anyone seen one of those before? Have you no idea what it's called? Actually, yes, it's not right. This is called a volumetric flask. And they come from the small, which is kind of cute, all the way up to the big. That's 5 litres. Now you see why the need for labelling when you're doing an apparatus diagram, because the conical flask and the volumetric flask aren't that far apart. That's the way I draw it anyway. Okay, so apparatus diagrams, fairly simple affairs. Usually you would show them with the pieces of equipment interacting with each other. So if one's positioned over another, then your apparatus diagram would reflect that. But again, we'll do plenty of these, so this is something which you guys will end up very familiar with. Okay, one last thing before we have a break. We just feel it's the last 10 minutes between now and past. If I wanted to measure out 50 millilitres, which is that line there in this measuring cylinder, 50 millilitres, I wanted to do it really accurately. Can I just put the measuring cylinder down there, fill it up and think, right, okay, that's 50 millilitres. So, Serena, tell me more about that. Yeah, you're on the right lines. You could get down to eye level, look through the piece of equipment and make sure that you are measuring it accurately. Well, we'll come back to that. Hold that thought. Go on, Owen.
You could like fill it up, load some and then like put the rest in the pen and then like see where you meniscus is.
Yeah, so we could actually, the way we filled it, we could fill it as accurately as possible, so we could use different pieces of equipment to fill it. You two both mentioned the meniscus. Serena, tell me a little bit about what the meniscus is.
Doesn't it? Because it's circular, doesn't it? Look like it's done, so it's
Yeah, that's certainly along the right lines. Ollie, can you add to that?
Yeah, like goes at the side of the glass.
Yeah, it does. When you fill a vessel with water, the water actually travels up the side of the glass. That's all to do with the way that the liquid interacts with the size of the glass and the air pressure pushing down on the liquid. But this bit is called the meniscus. And we have to take that into account when we're filling a piece of equipment. Again, don't worry about writing this down just yet, because there are notes on this in the next section. Does anyone know? Say, for example, we had the 100 millilitres marking on the piece of equipment that we're measuring to here was there. Would we want to measure to the top of the meniscus or to the bottom of the meniscus? No, it's actually the bottom. This piece of equipment would be filled to 100 millilitres if the bottom of the solution, actually yeah, so say the 100 millilitres is there. So it's the very bottom of the meniscus, or the very bottom of the lowest point, which is where you would measure to.
kind of like an illusion.
Okay?
Is it like an illusion? That's why you don't measure from the top.
Well, no, pieces of equipment, particularly accurate ones, will actually take this into account, take into account the fact that the water water travels up the side. It's the flattest or the nearest to flat point that you measure from. And actually, when you get to filling these things, and you get down to eye level, the flat bit is actually the easiest thing to measure to. Measure into the meniscus is quite tricky because it's usually very thin. So that's kind of the main bit. What's the other thing that you've got to remember? So if I was filling this up here and I was filling it with concentrated sulfuric acid, and I've got down at eye level, what's the one piece of safety equipment I'd want if the sulfuric acid got on my face? Yeah, safety specs. So this is another reason that safety specs are so important, because actually to fill pieces of equipment accurately, you need to be at eye level, but if it splashes out the top, then the first thing the chemical's going to hit is your face if you're sufficiently close. So that's safety specs particularly. Acid's not so bad because you can just wash it out, but alkaline's awful because it's slippery, the alkaline. It's really difficult to get out once it's in. Just as an additional thing, can you get a meniscus that goes like that? No?
Air bubbles travelling up, I suppose. No, I don't know.
Air bubbles, that would certainly disturb the surface, but you could wait for the air bubbles to go. It is actually possible to get a meniscus that looks like that.
If it was a thick liquid, would it do it? Really thick?
Yeah, I'll put.
Does it depend on the shape of the
Picture.
glass?
It actually depends on the type of liquid, and there is one which
Skin on it.
is really well. There's a really common one, mercury. Goes like that. Has a meniscus that goes like that. There probably are other things that do that, but I don't know what they are off the top of my head. But yeah, mercury is the famous one. Mercury is actually a great chemical. It's really heavy mercury, and the little pot of it is really heavy. But it's also quite toxic, so you're not allowed to use it in schools anymore, which is why. Although we do have some mercury thermometers, which if they smash, you have to chase the mercury around on the floor. But if you were measuring a fluid that went like that, you actually then measure the 100 millilitres up to there. Okay, so meniscus, get to eye level and make sure you're wearing safety specs for. Where's my flicker?
Over there.
Thank you, Luke. Okay, Curie, it's a dome-shaped meniscus and water with